Welcome to the Software People Stories. I'm Shiv.
I'm Chitra,
And I'm Gayatri.
We bring you interesting, untold stories of people.
associated with the creation
Or consumption of software-based solutions.
You'll hear stories of what worked.
and sometimes what didn't,
You will also hear very personal experiences.
and insights that would trigger your thoughts.
And inspire you to do even greater things.
Hi, you may wonder what Srinivasa Raghavan, known as SS or Raghavan to friends, a successful hardware entrepreneur, is doing on the Software People Stories. This is a special episode for me for two reasons. Not only is this the official 150th episode, but it also features a guest, a long-time friend, who was a key influence in my choosing software as a career. It was good catching up with him in this free-flowing conversation, where I also discovered some details about his thoughts and actions over the years. In this interaction, Raghavan shares how he got interested in hardware. I don't want to mention the spoiler in this intro. How being at the right place and time in solving a key technical issue made him take up an impactful role, and the experience of switching from employee to entrepreneur again. He also talks of challenges and joys of working on hardware-based solutions that have more and more software nowadays, and shares some guidance for aspiring hardware engineers. Listen on. And before that, a heartfelt thanks from Team Software People Stories for all the love that you have shown over the last 150 episodes. And please do continue to encourage us by sharing this with your friends and also rating us and giving us feedback. Listen on. Welcome to the Software People Stories, Raghavan.
Hi, thank you very much for inviting me here. It's a great privilege to be here with you. Yeah, I would like to share whatever that I remember. You had been asking me to share something, and I seem to be remembering quite a bit.
Good.
I will try my level best to actually recap and let you know.
Yeah, absolutely. So this is a very special episode for me for multiple reasons. One, of course, the podcast is now 150 episodes old, and I wanted this to be special. And right in the beginning, I had mentioned, I've been telling everyone that the person who was responsible or influenced me to get into software was you. And I've been wanting to get you as a guest, even though people may say Raghavan and software, Raghavan was more known for hardware. So you can start with your origin story, how you got into IT, and then what have you been doing? And then let's look at how we take it from there.
Sure. Okay. First of all, once again, I think you have given me a great introduction, and then you are giving me the honor that I am there in the 150th episode. Thank you very much for that thing, number one. Number two, you are giving me another great honor that I am the one who has influenced you, which I think it is by God's will. I don't want to say anything, because similarly, you have done the same thing to me, that you initiated me into the hardware. I should say that thing. Without you, I wouldn't have got into the hardware at all, because every time now I see the hardware, I feel a bit nervous. You must be remembering this electronics one in the first year, and then I used to be scoring very poorly there actually. If I'm right, actually, see, we used to have a small joke going on here and there, and then whenever we not able to understand or explain something, we say that's hardware. I don't know whether you remember. That's hardware. Don't ask me the question, kind of thing. So I'm always afraid of hardware, and I do not understand this biasing and whatnot. Okay, all those things. And then you were very familiar with that thing, of course. You had done so many amps, this, that, everything. And then you are the one who initiated equally. And then today, I should say that, I had a very successful career because of you. Okay, it is also equally, I have to also tell you that, because it is not one way. It is both ways that we got benefit. You got into whatever you liked, and I got into whatever I liked later. Okay, that was the very old days in IASA. I remember we used to just roam around here and there, and then you used to be actually always clinging on to your transistor and then listening to so many things. If I'm not wrong, I think that you will be listening to some I don't know, maybe broadcasting there. It's not podcast there then, and then I used to be listening, and then used to figure out. That time I was coming fresh from our Tamil medium. I can't even follow some of the things, to frankly tell you the thing. And then I had difficulty. And then I was one is that vocabulary. Second thing is that my strong point is used to be in English grammar. That is where I used to score. Even now, my grammar only has been giving me a lot of help. Okay, incidentally, I was standing first in some German class because of grammar, not because of vocabulary. Okay.
Oh,
So
wow.
I was actually doing like that. I learned German for about 3, 4 months, incidentally, for no reason. Okay, I'll come back to it later about it.
Hmm.
So then I used to be wondering, oh, Shivaguru is something great, and I don't understand this. I don't know. I mean, it so happened to us because of this network analysis or some particular. It is network analysis. Professor V. Krishnan was taking that course, of course, and that was a beautiful one, But everybody used to get only negative marks there. There is no positive mark at all. And then there used to be assignment, and after a few this thing now, that assignment will be getting into a theory. I remember one such thing, and then they have given us a transient analysis which we were not able to solve, and then we were forced to use slide rule, and slide rule was the toughest one to use. And whereas you remember this Mr. Vivek Dhawan, okay, he was having a program calculator, he was able to do things pretty fast. I was mentioning this to one guy called Prabhakar in the School of Automation. He said that no, with this programming, you can do so many things. That was surprise to me. I don't know what the computer do. Because I always think that is hardware. Okay, that is not my part of. And I started learning from this Prabhakar. But the man who once again put me so much on the track on this thing is FORTRAN is Vilango. Vilango is saying Vilango, even though he was in metallurgy, he knows everything. And then he used to be coming late to the class, but always standing first in the class. Okay, let's go. And I was that kind of assignment started much early there. I was actually visiting my native place, and then he was writing me letter that have you gone through this FORTRAN 4 program? Okay, like that. Okay, I used to give me all those things. Okay, so that was what happened. That's the only thing which I got interested. I remember that very well. And then I used to be spending a lot of nights in the computer center, and then preparing the cards. That time you remember this card punching used to be there. And then it was a nice one because it gives you a total mechanical feed. One side it gets spread, and the other side is just get printed and goes and gets stacked automatically. And we have to choose a proper machine. Otherwise, no, there will be a small skew, and then we'll get into problem with the thing. So there were, of course, other usage for the cards. We used to do rockets. Do you remember the thing? As rockets used to do it. That is a beautiful one, and those things were the initial thing. Of course, these interests have been so deep for me. Then I got into this software so much, meaning that how to solve the problems. It is not that okay, no, I was interested in doing the programming, that more how to solve the problems. And very fortunately, in the electrical engineering department, there are a lot of applications. People used to carry big deck, and by the side of that, civil engineering department used to carry deck. So I thought, okay, no, there is something for our career. Sometime later we can build. And that is why I got into it, if I remember. And then this is the thing. And then even though I used to appreciate the app and things like that, I never put my hand in the thing. And I was in E-Block, if you remember, just next to my room. There used to be a lot of music being played now and then. I remember still that Bonium used to be played, and then that's the one which has kindled me interest in hardware. I mean, how to do this app. I should do the app myself. That is when I started contacting you, how to get into the thing. And you were not very familiar with the computer programming. That is, you are not coming to the thing. I used to take you also, and then we were to just chat. And then I was saying the thing, no, you teach me hardware, and I teach you software kind of thing. And then it got switched positively, and then we have switched our career also in the life. Am I right, Sivaguru? I remember.
Yeah, absolutely. I still remember the first FORTRAN program for biorhythm that was written, and that worked well on the teletype. But then once it was fed to the mainframe through the punch cards, it got into an infinite loop. That also I remember. Then getting called to the computers and saying, "What are you printing?"
I even remember one more thing. If we were walking somewhere near that Sankey there is one side road which is leading to the power engineering department. I remember that vividly that is a time you said two things. One is that I'm going to allow my kids to do whatever they want. I'm not going to force them to do this. I'm going to give them full freedom. And then I also going to see the thing, I switch over to software. These are the two things which I remember. And then it happened. Okay, it happened, I think. That you done whatever that you wanted to do correctly, right?
Yeah. So how did you get into hardware? And then I know that you've been doing a lot of innovative projects even in those days. For example, the power line communication or the low cost. Today, everybody talks about IoT, but you had these devices in remote areas for weather or rain monitoring, collecting data and all that. So how have you seen the hardware space or your own career in that? And nowadays, you do talk a lot more about software in your solutions that you give. So maybe you can tell us about your story of what all happened, how some of these things got internalized, or how you adapted to those.
Sure. I will definitely let you know. Incidentally, there is one more thing happened in my career. I should say this. You must be remembering this. We were all in the frenzy of applying to various companies and all, and then they were coming there for campus interview. And then one such case is Tata Burrows, where you got into it, if I'm not wrong. Okay, Tata Infosys, Tata, I think later. Okay, Tata Computer, whatever. Tata Burrows was the one. I made a mess of it. While answering the thing, no, the same column I was answering for the second or third sheet also. So after somewhere I realized that okay, I was answering the same because already I ticked the column and then I was trying to do the thing. So that's something as I was saying that it is God's will only that it ensured that I am not getting into software by whatever means. Yeah, in spite of our interest or whatever, it ensured that I will not be getting into software. Then I was in the queue for Hindustan Computers, Hindustan Computer, HCL. And then I was third in the line. I think Jay Kumar, Raghupati, they were all from communication engineering. So they were actually the first two people who went there and then did the thing. I was third, if I'm right. And then they asked some question to Raghupati, and then Raghupati also came, answered it very well. He is a very highly intelligent person. And he announced the question to me, so I was also prepared. But when I went, the same question was asked. It was not asked for Jay Kumar. So I went there, and then I was trying to answer the question as though I don't know about it before. I'm only coming across now without any this thing I was telling. But they caught me that okay, you people were discussing and also I pretended I didn't. So what they did is that they twisted the question. That question was twisted so heavily that okay, I cannot answer the thing. But luckily, Professor Krishnan has taught us very well. I'm telling you that the theory is very important. And then I answered it, and then that scored the point. So I was lucky enough to got into that thing. That is how I got into hardware first. So now also I'm telling Sivaguru that same concept, whatever that I was asked, even though I am understanding that nobody in the thing is able to clearly give the answer. Still, people are hesitating to give the answer. I remember that even though sometimes I used to ask some of my new recruits, do you know anything about it? None of them is able to solve the problem. I do not know still. Maybe coming across wrong people because or this is not like IAC who taught us. I do not know. So that is my start of the career. But when I went there and then joined Hindustan Computers, and a very nice thing happened to me is that I was given into a disk controller. In the days, if I'm not wrong, there are 3-4 things which are very important: hard disk controller, tape formatter, and CPU. If any one of them you are in the project, no, you'll be able to understand the whole hardware funda. So it was very nice. Okay, now I got into this controller and I was leading the thing. Later I was made to lead the group also. Nice thing happened. And then our friend Mr. A. Kannan was here, and then both of us wanted to start something on our own. Once again, the same line, that hardware only. It is not that okay, we want to do something on software or hardware, but always our aim, or even now my aim is that do hardware, but put more of software in the thing. The software doesn't make it, no, they call it firmware, they call it embedded system, they call it IoT, whatever it is. Put more of software, make use of the full hardware. That's what my aim used to be. And then, okay, I learned almost everything. And incidentally, when I was there in that thing, the small stint in the Usha microprocessor, I even learned how to program at the OS level, how to go to the iOS level, how to give commands, things like that. So that gave me both the things door for hardware and hardware related software. I was able to. And I started with Kannan, and it was a pure hardware thing we started. And we started doing some projects for HCM, as well as Usha microprocessors, as well as one project I got in Micro where Infosys was involved. They had a very, very difficult problem that time because somebody who can somehow get that floppy data transferred to the mainframe only. I mean, they are in the project. So I told them that it's not possible for us to connect the device there because you are not allowing us to do it. I will connect the computer and then do it. So why I'm saying this deep note to you, the small things only actually in life, what I found is that a small thing, step you take it, and then sometime it become a big thing. I tell you why I'll just give you the weightage for the thing. I have done this, and then I was able to, I mean, I should not say with so many eyes, okay. What I mean by that, we were able to somehow finish it and then just show that working. They got totally satisfied with this. And then they gave me the job. And that time, there was no hardware section at all in Infosys. And then I was told, okay, what is that you want? I said that I want to lead a group. It is not okay, I want to do something. I want to lead a group. Don't bother. I may do hardware, I may do software, but I will be getting something worth for it. And then I started learning communication. I was not able to get communication in the IAC, but I started learning communication, which is totally strange because I was a power engineer. And then I started learning communication. I was doing BP, Lati, this, that, how the signaling is done, how the modulation is done, all those things I learned. And then fortunately, it was all very helpful to me. Why I said that incident very much important. That put my career totally different because had I done then during that time, because they were all software engineers. They were the Infosys full of software people. Had I done some other software and then tried to impress upon them, it wouldn't have carried any weight. But that time, what carried weight for me is that this hardware for only. Okay, so that I mean, in Tamil, I don't know whether you must be remembering. There is a saying that "Umeki odarova and chanda prasantal." Okay, meaning that if a person who is not able to talk much good, but he is better than the person who is totally dumb. Okay, okay, so that's good. Okay, so somewhere or that I was able to make it. But what I don't know is that I mean, what I came to know later is that that was a make or break for it. Infosys make also because they were about to get into a problem if they are not able to finish the project on time.
Mhm.
And since I helped, and then I got the good books. That is the reason why I was able to get whatever I demanded them. So I'm telling you, it's a very small step I have taken, and then it actually given the thing. So from then onwards, I want to be actually also sincere to my employer. So I started developing some products. As you said that some innovation, and I learned more of communication. That time, communication was the one which was not very much available in India. So we were able to do automation on telegraph network. And then it is not just a telegraph network signaling and things like that. I have to go up to the level of implementing Devanagari kind of thing. Why I am saying all the things that people should understand this. The technology was available, but we do not know how to put it to use then. So we were able to do it. We were able to put together and then give a good product for these people. So Devanagari script on a LCD was almost impossible. So I was able to do it. Okay. Even though I am trying to keep up my this thing, always do some small things, some innovation, something or other, something teaching them. For quite some time, I was doing consultancy kind of thing only for about 15, 20 years. Later, I switched over to some production, a small manufacturing. I'm having it happy. Okay, so this I'm able to command whatever my time. Whenever I want, I can do. I can do something like that. So that has that career was molded. I think during the talk what we had in IAC during that time, still, I mean that has put me on the right track. But what I feel is that most of the present generation, no, they don't have the full knowledge of what is that thing. Be it hardware, be it software, does not matter. They are not learning the full thing. They try to actually Google it, bring something here and there, and then just do it. It may work, but when they get into problem, they are not able to solve it. But strangely, a surprise to me is that my even my children, they adapt the same thing. My son is adapting the same thing. I say, I used to tell him the thing, learn it fully. He said, no, okay, I will learn only, but that's enough for me. Okay, so this is what is happening. But I am glad that, okay, I come to this hardware. It has really given me a good career. And then I was able to be successful. And then even though I am having this thing and I'm doing innovation, as you said, something or other, I'm keep going. Every day to day, there's something keeping me interested in the life.
A few curiosity questions, some things which we have spoken earlier also, but just for completeness sake. No, one is, where do you get ideas for innovation?
Oh, strange. Okay, it is not that. Okay, where do you innovate? First of all, I have not done innovation. Okay, you can say that necessity is the mother of innovation only. I mean, as you know it. I tell you what was happening is that in our, when we were moving from in the Jayanagar itself, in Infosys, I was going from one place to another place. And they were supposed to send, at that time that telex was there, huge machine, which can operate only when the power is there. Oh, no, sorry. No, I'm sorry. When power is not there also it can operate, but huge machine. And only thing is that you can't do a conversation of the thing. You have to prepare the thing. And if you do a mistake, the entire tape, the paper tape is a waste. And you have to preserve the paper tape, and then later you have to put it, and then one go you have to do all the things. And then I was most of the time, I used to be the only person in Infosys sitting here. All the people will be going visiting abroad, and I used to take care. I was almost handling the entire, even sometimes payroll also I handled. Because of this, I used to find a lot of problems in the administrative work. So I was telling the thing, why don't we do some automation on the thing? I mean, even the automation word is not correct, because that time I do not know that I'm going to automate it. We don't do something, we connect it to the computer, something like that. I tried. And then I started reading the thing, telegraph signaling means what, telegraph this thing means what. We used to do 5-bit transfers, which is very, very. One of the days, Nandan was supposed to give something what we are doing other than software, and then he was talking to somebody, and then he said, "You have done so many things, but only at a 50 baud. That is very poor. We don't do something at 9,600 baud." He said. Somebody was asking it. Why I'm saying that? That is the time. So innovation is needed then, and then we have done it. Because you want to connect Micro and Infosys in Jayanagar, somehow using some telephone signals. So that is one of the this thing we got. Similar thing when I was talking about this product. I mean, and to another thing, the director of Department Post and Telegraph, he was attending, and he said, "We can do something on that thing. Can you automate the telegraph network?" So that is how we got into it. Same thing here. Once again, when I'm right now here, you are talking something else totally. And one NGO said that, "Can you measure the rain?" Yeah, why can't we measure the rain? It's a very simple thing. Then he said, "Okay, automatic." Oh, we can do automatic. Why? What's the big deal with that? I mean, I used to say, okay, it's not a big deal, but we have to work. Okay, we have to that behind the scene, whatever that we work, we'll not tell them. So we have done it, and then that is thing. Sometimes you see here say sometimes necessity. These things will be used to drive us in doing some innovation. It is. I don't say that it's a big innovation. It is something which is already there, but we try to put it in use, and we try to also make it a useful product and which it is saleable. That is what.
So taking a cue from, let's say, the transition you made, or the way you expanded your own skill set and what you can influence, which is coming from hardware and then learning the software, using software to make the hardware more flexible, etc. Is the reverse possible? That is, somebody who has been in software, if they want to do something in hardware, is it possible?
Definitely, I think it should be possible, but you need only a little bit of fundamentals in electronics. Okay, that is the only thing. Strangely, if you are not going to do designs, if you are going to only use hardware, you can definitely switch from software to hardware. Most of our engineers, what I used to tell them is that learn hardware also, and then they are all coming from the software background. And then I used to put them on the hardware with respect to writing the software. I used to tell them that learn yourself with the Acrobat reader, whatever PDF files. All those things they used to go through it and then understand all those things, write it down religiously, and then do it. But not all, only very few people. But they can do it. I have seen people, they are capable of doing it. And it is possible. It is not that it's not possible. Nowadays, there is one good thing happening is that there is something called Maker.io or something, so many things are there now. And then most of the hardware is kind of available off the shelf. If you want to do some controls, available. If you want to do some sensing, available now. So you do not have to worry about anything. And then it's also packaged in such a way that it is pretty cheap and to do something. This is for the small hobby kind of thing. But if you want to make it a product, industry product, and then where it has reliability, we can make it work. That thing you have to do some work on it. That may not require so much of hardware knowledge. A software person can get onto it, definitely. It is possible.
Yeah. When I said hardware, it is not just the electronic circuitry, but also the box that you put it in, etc. Because the reason I am asking this question is because I've been coaching a few firmware teams, as you say.
Mm-hmm.
Now, for them, it is not only the algorithm. And earlier we used to talk about how do you make it efficient using less memory and all that, which Normally for an application, you don't really bother. There's enough, and you say on the cloud, if you want, you can dynamically increase, reduce, all that. But when it comes to an embedded software, not only those, and how much data can you log there? Now, after some time, what will happen if it is not connected immediately? And then the conditions on which the device is deployed. Now, like we were talking earlier, will, let's say, the heat conditions change maybe the clock rate, in which case will your algorithm work, etc. So how do you get your engineers to understand this?
Very, very, very apt question, Shivaguru. I think that you are almost asking all my problems, whatever we are right now solving. Not right now solving, you've been solving for last few. It is a typical problem in any of the hardware industry. And particularly, you are talking about 24/7 devices. And most of our devices are 24/7. It has to work continuously and also exposed to what all type of weather conditions. Because we are measuring the weather, okay, measuring weather parameters. So it has to be like that. I tell you, first question is that your question is that how are you managing the boxing and all? To a great extent, I don't give much to the ergonomics design and all. I don't give much thought to the thing. In the beginning, we do something and then we make it work first functionality wise. Then we bring a fabricator and then just do a simple enclosure for this. Later, we start doing something better than that, and then we give importance to it because we do not know much about the mechanical things. But nowadays, whatever that sensor we are doing, that requires a lot of mechanical understanding, mechanical engineering understanding, fundamentals. I tell you one such thing is that even the typical, I say I am right now, let me tell you, I am more involved right now in rain gauges, rain gauges and weather station. Rain gauges is anybody can do it. I don't think there is anything great. But a lot of people have put in effort. One problem is that you have to do a calibration in the field. What's the meaning of calibration in the field? See, the bucket, when it fills up, it tips. So you have to put it at a particular height and then only it can tip. That's what. The height fixing in the field is pretty tough because we used to use a check net and things like that. So that required a innovation. I understand. I think if I'm answering correct. What we did is a kind of one mechanism where the check net is inbuilt kind of. And even now, I have taken it to the Indian Meteorological Department. They said it's a fantastic thing you have done. But we didn't patent it. We said, okay, anybody who wants to see that, okay, say that, okay, if you want, you can use it. And that's the one which is helping me in the thing. So that is the mechanical thing, which we said, we got one mechanical engineer. We told him that, okay, no, this is what we wanted. It should be, checknet should be inbuilt. I mean, you cannot even believe it. It's a kind of this Maruti van jack, I remember. Like that only we did. Okay, it worked. And then I want to have a motion this side and it should be translated. So blah, 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 because I don't know much about mechanical engineering, but I told my specification, he did it. He did it and it's working fine. So that is one of the things which I can tell you. Definitely innovation is needed. Coming to the problem of this real-time clock or something, whatever that you're saying, the clock and all this. This is another typical problem which you used to have. What I used to do is that, I used to sync with the time sensor servers in the cloud. Okay, not only I have a local real-time clock hardware, sometimes it misbehaves. Not sometimes, many times it misbehaves. So the battery will go, the cell will go, and this will not be proper connection. Something will used to happen. So we used to, now and then we used to take the server. Of late, we were having HTTP protocol and then we used to do the thing. I don't want to get into the nitty-gritty something, but anyway, there are solutions available, but you have to think the solutions are there in front of you only. Until, okay, a similar thing, power. We had a power problem in the beginning. So we said, okay, no, let us go with, incidentally, if I'm not wrong, when I was developing this electronic telex in Infosys, I have somehow thought, okay, now why don't you use the battery and then use a SMPS thing? I never thought that is a DC UPS. And it became a kind of standard. We never claimed that that's a standard which we had developed. And we are the first one to have come out, we are the first one to have come out with electronic telex India. We are the first one to have come out with the electronic telegraph. But it's all small thing. I mean, because people are trying to go with modem and something is satellite communication. We are talking about automating. And I was doing this automation till 2002 or 3. Then I think that SMS came and then it took over everything. So innovation is possible. Innovation is there in front of you. The requirement is in front of you. Only how to put it two and two together, how to get it done is brain. That's what. Think quietly, you will get so many problems solved. There is one such thing still in my this thing is that one of these days I have to somehow learn this digital signal process. That is, I am not able to actually put my hand on the thing still. I was very fond of it for some reason, but I am not able to put my hand on the thing. Every time I do 2, 3 chapters after the thing, it goes up. It just butterfly. So many things are flying above my head only. Okay, right.
Yeah,
I think
nowadays,
question, it needs a lot of innovation. Definitely, it is not something difficult. When the problem is put on the thing, take it, approach it very with determination, you'll get it with passion. Okay, one thing is that most of the people are doing it for just to score a point with some colleagues or something. That won't work. You think, I mean, what is the best you can give? The passion is needed.
Yeah, very nice. Along similar lines, but probably, are there stories of things that did not work as you intended? And maybe later when you were debugging or you're doing something, saying, oh, how did we miss this? Are there any such stories?
Yeah, there are some stories, definitely. In the same time, when I was there, there was a public call, a PCO thing where, so I was not able to put my hand on the thing. The reason was that, okay, one is an understanding problem. I'm not a communication engineer, even though I was not formally introduced to the thing. I was learning myself, and so I could learn everything, whatever I wanted. But I not have the full spectrum of what is the thing to be done. So I do not know definitely the telephone characteristics, telephone 9 characteristics. We missed it actually. And then that was done by one of our competitors there. And so we find there, okay, there is one thing. And similar thing, whenever we try to put two and two together with some part of the equipment, like SMPS kind of, there we failed. Okay, I mean, it's not that, okay, now we are thorough in all the things. Later, okay, that had it been available to us, had that knowledge been available to us, we would have done it. Yeah, definitely gone through this phase. It is there. It was there. And even now also, we are having a lot such things. We do not have something is not available in India, so we cannot help it. We are not, it's not that, okay, we are not capable of doing it. Price is pretty high and funding is not easily available to us for those things. Such things make this kind of stories.
Yeah, my interest and admiration for hardware kind of still continues.
You're welcome.
Yeah.
Join our group.
In fact, yeah, my B project was also a single board microcomputer and all that, where we wrote the OS, bootstrapping OS, etc. Now, but the thing that I start appreciating more and more now, even after so many years in software, is the discipline that hardware engineers bring. One, in terms of design, the version control, so to say, every component, every connector, every interface, everything being identified, baselined and all that. Whereas in software, it's more of a trial and error, and there are a lot more combinations that you can try out before arriving at the final solution. You have experience in both, and your team also will have a mix of probably hardware and software engineers. Are there any lessons from hardware or any practices from hardware that will help us create more robust software? Not necessarily rocket science type of thing. Even otherwise, what you write should work, preferably the first time. Are there any tips that you will have for the software developers?
Okay, yeah, but I appreciate your question, definitely. But I doubt your assumption. These harder people are disciplined and perfect and things like that. Because I used to always come across people, they don't do things properly. Then, I mean, every day we get into the discussion, okay, arguments and then fighting and things like that. Yeah, because if you take a mechanical engineering, they're much more perfect compared to a hardware engineer in electronics. Because particularly the digital people, they don't do a proper full discipline thing because this thing is most of them 1 and 0 only. They don't bother. When it comes to the PCB, the design is not horrible actually. Incidentally, we initially used to do the PCB also ourselves. Later, I started giving it to consultant. But then I found that those people are not having the knowledge. Okay, so they don't know which signal has to go where. I mean, if it is high frequency out, many people don't know. So there is no discipline. That kind of discipline is there. It is compared to software. I can say yes, these people are somewhat organized because there's necessity. They can't say that the connector can be put in this side or that side. It won't work. Okay, that's the thing which is happening now. And then they don't do a proper marking of a pin number. Nowadays, everything is CAD, everything is available, but still they miss. Still, okay, no, for example, okay, the resistor values need not be fed in the circuit diagram. They can redesign the circuit values. You have to put some resistor, some capacitor, something like that. They leave it. And later they can think about it, but they never give time to think about it. They never freeze the design. So at the end of it, no, I mean, when you go to something that R&D time, no, it will all work, no problem. It goes to production, which thing were gone. Okay, we have to break our head and go to the beginning. So on one hand, I am not agreeing that thing. No, they are disciplined thoroughly. They are disciplined to some extent. Because they have the freedom to do something at the end of just before the production starts. That is one thing. But they are definitely better than the software people, because software you can very easily can change, also do it. I don't say hit and try, but there is one thing in software is that, if I'm not wrong, please correct me, most of them is available now in the Google. They use the GitHub, this and everything. Just take it and then just plug it in and then it works. I do not know. I mean, still, because I am also taking some codes here and there and just making it work. But because I am not a software engineer, I'm not doing a software project per se. But you tell me. But most of the code which is posted in the thing, yeah, they are person who is posting it. They have done a thorough job. So since if you use his code, if you're using it as a library, no problem. But your code has to be perfect. And how to do that? I don't know. I mean, I think that the practice which we are trying to do is that discuss in the beginning and freeze the design or something like that. Never happens. Okay, it never happens. And we say, okay, all sorts of jargons we use, top down design and then bottom up implementation. All the things are good to talk about it, but nothing happens. Everything is only bottom up. As and when whatever that you require, only we do it. As and when we require, we remove the model and then just copy some old model, something there, get into problem. Okay, it is always the case. Okay, but it's all good to talk about it. What we did is nowadays we don't. I don't know. Our engineers don't believe in Git backup. They only have local copies. They have every day one backup. They do it. That's the one strict thing they are doing it nowadays. Before starting the morning religiously, they come and copy the thing. The next one, start the day. Okay, so then okay, if there is any change, okay, it only this much spin. But version, so many versions. If I'm not wrong, so many versions. Uh, I can't help it. Okay, I don't have a solution. If you have a solution, you have to settle me, because I am not a software person to do that. But I am also having the same problem. Similar, we are sailing the same boat.
Then the related question is that nowadays, as you said, there are a lot of including fans come with some controller with a remote control and all that. So the cycle times or the process for developing hardware, testing it, and then finalizing it versus in software nowadays, a lot of teams are looking at, let's say, 2-week kind of increments, saying, let us do something quick, something small, and then build on it further, etc. Do you have such kind of practices? And then if yes, how do you kind of synchronize the two? That is, if software says that, okay, let me give you something in 2 weeks, you just look at it, let me know whether it is okay, I will correct it and so on. And the hardware says I need 3 months.
Correct, you're right. And we'll definitely start working by the end of second month. Not before that. Okay, it is always the case. It is not something new to anybody. We are not Six Sigma people or something like that. Okay, nowadays I don't think Six Sigma is not existing at all. 3 months time, if you give, definitely first month no work is done. All procrastination only. All sorts of these things we'll do like this, we'll do like that and all. And suddenly one day we'll all wake up and then do it. Okay, now yes, to reduce the cycle, what we have done in hardware, what we have done is that indigenous as many things as possible. Okay, so don't give it outside. Do it yourself. Okay, don't give it outside. Learn, how to do PCB CAD. Learn how to do this thing. Okay, learn how to do the mechanical drawing or something. See, mechanical drawing, once again, you depend on somebody. I might as well have one person here and then tell him to do it yourself instead of giving it out. Indigenization is helping us actually to shorten the cycle. That's one thing I saw. And then some places where you can experiment it with existing hardware, which can be bought out item or which is already available to you. You use it definitely and just try to experiment it, see the feasibility. Then only you put your hand on the final circuit. So like that, okay, now we shorten that thing. But as you are saying, is we used to take a lot of procrastination, time, and definitely 50% of time is wasted. And suddenly we all wake up, and definitely the customer will write a letter, what's happening. Then we'll all wake up and then start doing things. Some places we said that we can't do it. Okay, we just forego that also. We'll give a reason that funding is not there. Okay, that's not the actual reason. Else we are not working on the thing. That's the reason.
So normally close the conversations with some career advice. Of course, I know that there are a lot more stories that you have told me earlier, but we'll probably do that another time. But if someone wants to look at hardware as a career, because on the podcast, we've been asking people for advice in terms of getting into software, but I think you are uniquely qualified to talk about both. So if one wants to either get into hardware or this other question that I get a lot from mid-career people, particularly in Bangalore, is most of them think that writing an app is becoming an entrepreneur, but some of them do have a little more deeper thought and say that I want to create this product, which is a hardware software solution. What tips would you have for them?
Good question. Okay, because I'm in the hardware thing, I am not saying that thing, okay, that everybody has to get into hardware or something like that. But hardware is definitely a very interesting. There is no doubt about it, because you can see something happening there. Software also something will be, there is no doubt software also a lot of things are happening. It's not just a few things. But actually, when you want to demonstrate to somebody, when you want to make something, okay, do a little bit of action, that comes that you can get it only in hardware. And I'll just digress for about a moment. See, if you are thinking about a latch, if you're thinking about there is memory, if you're thinking about yes, simple gate, okay, not all those things, no. See how these people would have struggled in the early days when they were having only mechanical things. That I was going through it one of these days. I had gone through it recently. I was actually trying to develop water rationing mechanism for agriculture. And then there I was trying to see whether we can do all the things in mechanical itself. It was not possible for me. So I have to introduce some bit of IoT kind of thing there and then do some actuator and all. Why I'm saying that thing, no? All those things, whatever that in the historically, whatever that have been difficult to achieve. Okay, amplification. When you talk about amplification means that okay, you are giving a particular voltage that you are able to a small thing you are able to make it amplified. But those things are not possible in other engineering, like mechanical engineering or civil engineering and all. It's pretty tough. So you will definitely love to see that whatever that you do is also you all can also see the action in the hardware. That I'm talking about electronics. And another thing is that you can play around with a lot of software in hardware. It is not necessary that you have to do everything in hardware. Even nowadays, even the analog things also you can do in software. I mean, that you know it. That is what I was telling that I was not able to put my hand that digital signal processing. You can do all those things there. So whatever that you want to do achievement, do something, all those things in action, you can do it in hardware. So that makes anybody interested in the thing. That will give you a lot of interest. So for that interest, okay, people can get into it. But that is, if you want to build a career out of it, I do not know the career exactly. They can switch over as long as they have the passion to do that. They can definitely do it. Okay, as we are talking, you have to bring in some new ideas, new products. There are plenty of application, plenty of requirement right nowadays. But people are not looking at it. We also took the safe path. Okay, no, this we'll do because okay, since I am coming from the consultancy background and simple manufacturing background, I am taking some very, very simple approach. Okay, no, this is a requirement by this, and there's a huge requirement. So we'll do it like this. But for that, there are a lot of other requirements easily available. Some people are making it as a commercial viable product. Some people off-the-shelf product. It's all possible in hardware. People can get onto it definitely. But maybe it's a bit difficult in India. That is what people used to say. I am also tasting the thing. No? If you're working with the thing, it's a bit difficult to do it in India because you do a proper quality thing product. Okay, that's the only thing. Otherwise, I don't think we are capable of doing it. Our students, our engineers, our people are much more capable of anybody. And then I have seen people who are coming from the software background. They, whenever I teach them, and they are able to get onto it pretty easily with ease. Okay, they are able to grasp it. There are a lot of opportunities that it can be done. And I wish them they do hardware. If not for a full career, at least part of the career they can definitely get onto it. It is definitely useful to them. There is no doubt about it. And still, hardware is growing and will grow much more, similar to software.
That is very reassuring. And on that note, let me thank you, Raghavan, for taking the time to share your interesting journey and particularly your tips or how you've been approaching innovation, or when people talk about megahertz and gigahertz, it was good to hear baud, right?
Yes. Incidentally, when I'm using, okay, I don't want to digress now. Incidentally, it is much low. Okay, baud bills. Okay,
Yeah.
Okay. So, great. Thank you very much, Shivaguru.
We thank Siddharth for the music and Anita for promoting the Software People Stories.
If you like this episode,
Please subscribe on your favorite podcast client.
And spread the word in your network.
if you'd like to share your story,
Contact us at podcasts@pm-powerconsulting.com.